What you're looking at here is naturally dyed, enzyme tanned, bioleather made from microbes using waste as a regenerative source. And that sounds really exciting, but is it? Is it better? And that's one of the questions that this research kind of set out to investigate. The linear make-take waste economy of textiles built on industrial agriculture and petrochemicals make it one of the most polluting industries in the world. And most of us know that. But that's not what I want to talk about today. What I want to talk about is the solutions and how we can give our students and our community the tools to assess the true impact of their design decisions and consumption. So something I think many of you know that I'm really excited about is looking to nature's strategies for materials innovation. And as we try to bend that linear, extractive, wasteful economy into a circular economy, we see biofabrication as a strategy that's emerging to fuel a bio-based circular economy. And in biofabrication, it's the cellular machinery of microbes that takes center stage as the fiber factories of the future. Here's a time lapse of one of my favorite classes of bacteria. When you feed them some basic nutrients, sugar, nitrogen from rotting fruit or vegetables, these little bugs that you see as rectangles are spinning pure fibers of nanocellulose. And if you guys are familiar with textile development and materials innovation, nanocellulose is a really coveted material, but generally takes a lot of chemicals to produce. And here you have these little bugs doing it for free because it's a basic part of their cellular metabolism. This is the same bacteria that's responsible for kombucha fermentation. They've been used in food industry for 2,000 years. And because they grow, it was discovered that they produced this microbial cellulose in 1855 by somebody Brown, who was fermenting vinegar. So one of the inputs has to be sugar, and sugar can have huge environmental impacts. So here you have a time lapse of seeing a couple of different sugar sources with the idea and growing the cellulose on top. So that pellicle you see at the top that's kind of being lifted up by those bubbles, that is a hydrated pellicle of pure bacterial nanocellulose. This time lapse was taken over about 2 weeks. So we have a possibility for really scalable biosynthesis using sugar from waste streams as a feedstock. This can form the basis of a circular materials economy, and I've had great fun with my design colleagues and students at FIT, including Amy, who's going to chat next, as well as Anne-Marika Verplochase from the footwear department, designing with these materials. And it's really, the material is a very sophisticated modular engineering platform. It can be molded to shape, it can be grown to shape, it can be naturally dyed. And what I've done in my research is develop an enzyme-based tanning practice that takes this material out of an unstable biomaterial and actually turns it into a bioleather. I've worked really closely with Amy on building containers, rendering 3D print models, and having fabric grow exactly to shape, where you create products which at the end of their useful life, they can be composted, returned back to a healthy ecosystem, and provide nutrients for the next generation of materials. So here is a zero waste bag. The color was grown directly into the bag, eliminating both the toxicity and water demands of traditional dip dyeing. Marika did the construction. Amy helped me with the rendering and design and the vessel and the pattern making. We've made 3 of them. These are all naturally dyed. The one on the right is the kind of as-grown color. The one on the left is from cochineal beetles, which have been around since about 500 BC in Peru as an ancient dye. And the one in the middle is just with the tannins removed from the growth medium. All right, so is it better? So what are the impacts? And so this is one of those things where 1 year of work at the Navy Yard or remotely through the Navy Yard results in one figure. But I worked with my students to compare the entire impacts for a cradle to gate life cycle assessment, which means from the manufacturer to the product, not including use or end of life. And it was compared 1 square meter of material, cotton, leather, vegan or synthetic leather, and our biotextile. Two scenarios were considered. One where we used agricultural sugar as our feedstock to grow the material in the lab. And the second, I worked with the Ohm Kombucha factory in Mount Kisco, New York, and took the byproduct from their kombucha fermentation and applied the same strategies. And the results are in. The blue are the biotextiles. The biotextile 1 is using sugar, agricultural sugar, as a growth medium. Biotextile 2 is using waste as a regenerative resource byproduct that can support also a circular economy and small businesses. And you can see the impact reduction is particularly dramatic compared to the toxicity of cow leather and the carbon footprint of both cotton, plant-based cellulose. So this is bacterial cellulose versus plant-based cellulose, a cotton bag, as well as vegan leather. The carbon footprint is extremely high for vegan leather, which decimates biodiversity and then is a feedback loop to dramatically worsen climate change. So we see many benefits in designing with the materials. We have many of our FIT students designing with these materials. The impacts are significantly lower. We feel that we can publish this work and really quantify the impacts. I really want to acknowledge the really broad, diverse team that helped out with this. Students across fashion design, textile development, marketing, fashion business, surface textile design, fashion design. The whole team really worked together to put this, to kind of assess these impacts. Future work coming up, I'll be looking at the effect of natural dyes versus synthetic dyes in more detail. And thank you so much for your attention.
Wonderful. Thank you, Theanne. So do we have questions for Theanne?
If you have a question, you can either option to raise your hand or unmute yourself. Of course, Michael has a question. Let me find Michael in the list.
I'm unmuted. If
you got it. Okay.
Yes.
Go ahead.
So, Theanne, this is such great work. A couple of questions. In that slide where you were assessing the impact, total impact of leather was very high. Is that due to, but a lot of the other factors were relatively low. Was that due to the tanning and a dyeing process?
Yeah, so in this, in our database, which is the EcoInvent database, leather is considered a byproduct of the meat industry. And therefore, you might notice if you look at the right, the carbon footprint is considered to be very, very small. Yeah. However, simply because of the chrome tanning, it's so highly carcinogenic and so toxic that it fared the worst out of all the materials. Vegetable tanned leather, and using traditional practices would have leather come in much lower than synthetic leather. But because of the chrome-based tanning,
yeah,
that's really the big.
Yeah.
Another interesting development that I just recently was made aware of are people who are growing leather from T cells, which is, I don't know whether that'd be an interesting kind of comparison to see where that fit in the total life cycle, whether that's good or bad.